Um, Hello, everyone. Welcome to our event tonight. We have Gus Von Rohn, Executive Director and Founder of Omaha Permaculture, with a fabulous presentation over Omaha Permaculture Design and Energy. Just a few things to go over. Cameras and microphones will be turned off during this presentation. There is a Q&A section while we are going on listening tonight. So if there's any questions, feel free to type those in there. Ideally, we will have a little bit of time reserved at the end for Gus to answer some of those things for you guys. And we will be launching a poll towards the end of the presentation. If you guys don't mind taking a moment to fill that out, let us know. It kind of helps us plan some things for the future and what we can do better and continue to keep doing. So with that being said, I will pass this over to Gus and enjoy, everybody.
All right. Thank you, Morgan. Well, I guess we have about a minute or two before it's actually 6 o'clock. I might wait a little bit longer here just to see if anyone else filters in. It looks like we have now 8 participants. But I guess I'll go ahead and start then. It's just about 6 o'clock. Well, my name is Gus Von Rohn, as Morgan said, and I'm the founder and executive director of Omaha Permaculture. And I am excited to do these monthly webinars. And last month was focusing on permaculture design and edible landscapes. There is a recording with Conservation Nebraska. You can inquire to find out more and see if you would like to hear that recording. So tonight's topic is one of my favorites, energy, especially in permaculture design. The way we talk about energy is how much are you conserving and how little energy you are using to keep your system running. In permaculture design, energy is not really spoken about very much. But in order to have a cost efficient as well as a fossil fuel and climate change considerate design, energy is something you definitely need to consider. So I am going to bring up a PowerPoint tonight, another one, so you don't have to look at me very much. And let's see, I'm going to share my screen here. And let's see, I'm going to press play. All right. I hope everybody can see the PowerPoint. So as I mentioned earlier, my name is Gus Von Rohn, and I am excited to leave this webinar this evening. And I guess I'm a jack of a few trades. I do quite a few things to elevate the discussions of sustainability and permaculture in Nebraska and the Midwest. So I'm going to focus on 3 different things tonight. The first one, I'm going to give everybody, in case you haven't seen previous webinars, what is permaculture? And then secondly, I'm going to address the topic of the evening, why is energy so important when designing your permaculture system? And then lastly, I'm going to talk a little bit about the nonprofit that I run, Omaha Permaculture, and talk about how some of these permaculture principles are used in our nonprofit. But please feel free to ask questions along the way. I don't have a lot of slides this evening, as many as I used to, or in other formats. So I'm going to take my time. I'm not going to speak too quickly, and I'm going to pay attention to the chat box up here. And if you have questions, I mean, we can wait till the end, but I don't mind addressing the questions during the actual presentation. So to begin with, permaculture is a philosophy guided by ethics. We take care of the earth, we take care of people, and then lastly, when all of those needs have been met, we we devote excess time, money, and energy towards your community. So it's guided by ethics. It's not necessarily a market solution or a way uh, to provide, market dynamics, but it is really a way to get you closer to your community, to your neighborhood. And obviously, the principles inherent in permaculture do make your farmstead or your home more efficient. And so you are saving money. This is definitely a cost-saving endeavor if you get into permaculture. And so I'm going to be talking out a long-winded permaculture definition that I like to break up in about 9 slides. There will be a slide at the end that kind of summarizes all of this, but all of the phrases up at the top are part of that longer solution. So permaculture, if it is also a philosophy, it is sustainable land use design. So as you can see in the picture in front of you, we have kind of a contoured landscape that could be Nebraska. You got a river, a ravine, a little kind of valley of some sort with some steep slopes, ridges. But in permaculture design, you understand and learn how to use the landscape to your benefit. There are steep slopes. You can grow things a little more effectively down from this slopes. If you put your homestead up on the high ridges, you're going to be spending more on energy to keep your house warm during the winter. But if it's tucked in the valley facing south, you are blocking from the wind, so you actually are probably using less energy. And then similarly, being able to use the ravine is where water collects. So your growing season will be a little bit more effective because moisture collects at the bottom of the valleys, whereas oppositely the ridges is where wind will dry them out quicker. So understanding the dynamics between what is going on your land and where do you sit in relation to your ambitions is something important to know in design. Next, permaculture design is based on ecological and biological principles, often using patterns that occur in nature to maximize effect while minimizing energy. Sorry, I got covered on that picture over there. And as you see in front of you is 2 pictures of nature's designs. So the meandering way of a stream is a way that water deposits silt and floating particles as each time the bend, it silts out, and so thereby clarifying the stream as it goes through the landscape. But it is also a way to you eventually build and carve its new path over years. And then secondly, the pine cone is talking a little bit about how using the Fibonacci spiral, using that spiral, and as the pine cone opens up, it is a way to kind of spread out the seeds throughout the landscape. And these are the ways that nature has followed patterns that are very important. And in permaculture design, it is definitely important to acknowledge that these patterns are there for design and for efficiency. And so this is something that we can take a cue from. Permaculture design aims to create stable, productive systems that provide for human needs, harmoniously integrating the land with its inhabitants. So I kind of looked on the internet to try to find the most harmonious picture where we show people farming the kind of mid-grade landscape, and then keeping the higher landscape a little bit more natural with deciduous trees, because that natural landscape's on the top. We're going to be using the energy of gravity that allows the deciduous leaves and the silting and to basically build up soil over time. And similarly, the ridge will actually collect moisture as that dew falls on the leaves, and thereby benefiting the arable land below it. And those terraces do a very good job of catching everything so they don't just fall straight into the lower areas. But this type of system looks like it's allowing enough for nature, and it's still producing a product and produce for mankind. The ecological processes of plants, animals, and their nutrient cycles, climatic factors, and weather cycles are all part of the picture. And this is all for design. So you may not be able to see all the little details in these pictures, but on the left, you see animal life cycle pages. We're talking about the chickens, we're talking about bees, native bees, as well as butterflies and the insects and their life cycles that sometimes begin in the earth and the soil, and they break up and they aerate the soil. They break off exoskeletons. All of that is dynamics that are seasonal and predictable and affect your natural environment and part of your landscape. And then on the right, another part of the cycle of life is understanding when do we get our wind? When do we get our north wind? And then when do we get our south wind? And this past week was a good demonstration of both switching very quickly. So we got a 72 degrees on Monday, and then we got all the way down to 6 degrees just 2 nights ago. So Nebraska is a very good example of paying attention to these cycles and these wind patterns. In permaculture, inhabitants' needs are provided for using proven technologies for food, energy, shelter, and infrastructure. And so this kind of profile you see in front of you is something called an earth ship. A landscape or actually an architect back in the 70s, his name was Mike Reynolds, came up with this. And the most famous feature you can see is right there in the middle there. It's the rammed earth tires, and that's a thermal mass. But in general, the theme of his architecture is to reuse a lot of reused materials and upcycling. So he even uses old bottles to kind of make glass walls and thermal mass. But as you can see, you have production models of energy, wind and solar there. You also have filters to catch rainwater and then provide that water to clean and clarify that water so that you can use it for your utilities. And then there's even gray water filtration and being able to use it for plants outside. And then obviously absorbing some of the solar energy on the front to be able to grow things in the building itself. So I guess there is an earth ship that's been built in Kearney. It's just a couple years old, but they do accept tours from what I have heard. So I think maybe just looking on social media, you might be able to find and be able to tour an earth ship right here in Nebraska. Elements in a permaculture system are viewed in relationship to other elements, where the outputs of one element become the inputs of another system. And this is kind of a generic kind of demonstration here showing about how there are inputs to your farmstead or your home, and then there are outputs. But in permaculture, a cycle or a circle is very much an ongoing theme, as it is in life, and through the seasons and the nutrient cycles. Similarly, there are no wastes from a permaculture system. Those wastes they may be outputs, they may be something that is part of your production model. Well, all of those wastes actually become inputs for something you are doing in another system within your permaculture design. Within a permaculture system, work is minimized, waste become resources, productivity and yields increase, and environments are restored. So actually, this is a before and after of a landscape in the Middle East. Jeff Lawton, who's one of the best practitioners of permaculture, has refined a process of using drip irrigation to encourage the first plantings to do well. And then once those first plantings do well, it makes it easier and easier for the succession of other plants and trees to take root. Even in a sandy desert context like this, permaculture is capable of doing very, very amazing things. Uh, and then here's two examples. Permaculture principles can be applied to any environment, from dense urban developments to individual homes, and from farms to smaller and large scale regions. So the picture on the left is a 2.5 acre property of Omaha Permacultures in North Omaha. And you can see the skyline of Omaha in the background. So this is a micro but urban scale. And then the picture on the right is Mark Shepard's farm in Illinois, and this is about 160 acres. And you can tell it's not your typical kind of monocrop situation. He's using trees, and he's using kind of the contours of the land to make these little kind of curls and curves that follow the the contour of the land as it goes through hills and it goes through down to the ravine. And all of these are very effective ways to capture every bit of moisture and not to let any of your best soil leave. So lastly, this is the definition that I've been going over for the last slides. If you wanted to kind of read it all at one, because there's permaculture does quite a few things. It's if you do remember anything, it is definitely sustainable land use design. But today, I want to be able to talk a little bit more about the energy component, and that was probably demonstrated in that one slide with the earthship. But if you wanted action in your permaculture and you wanted to immediately do something in your community, these are 6 simple things that you could do. 1, catch and store rainwater. 2, what pretty much everybody knows permaculture for, grow your own food. And then 3, a lot about what we're talking about tonight, create your own resources. 4, also what we're going to talk about tonight, build or retrofit your home to heat and cool itself. So that's the exciting part. And then 5, reduce or create zero waste. Zero waste is definitely an important part. And then lastly, I guess what differentiates permaculture from a lot of other market solution terms and definitions, get to know your neighbors. Your neighbors have skills and talents and ambitions that may complement what you were doing and help you in a lot of respects. And just getting to know your neighbors, is definitely helpful, and in being able to create your own little permaculture oasis. So, why is energy so important in a permaculture system? Energy is provided by the sun, the wind, and the earth, and for free. Capturing and retaining that energy is the intelligence in the design. Every amount of money not spent on fossil fuel energy is potential profit. So this is all something that is about energy savings, but it's also about cost savings. So system efficiency is the primary goal in a permaculture design. What is permaculture design? So I'm going to go over a few concepts here and ways in which, if you were laying out your own backyard or your own homestead, what would you do? And so on the left here, we have kind of a layout, an overview, an aerial view of your home, and then being able to understand where's north, what's south, east, and west. And then you can see the little graph in the corner, which actually I have other explanations, and is the zone system, zone 1, 2, 3, 4, and 5. And that is covered in the graph on the right-hand side. Zone 1 is the immediate proximity around your house or your dwelling. Zone 1 is the most likely place that you are going to visit every day. And you want to design this area with high intentionality so that you can pass by zone 1 and be able to harvest things that you know you could use daily, your herb spiral, things that you know you will use regularly. And it may be between your driveway or your garage, or between your walk home or where you park your bike, and then to the front door or your back door. So that would be generally zone 1. And then successively, as I'll go into the next slide, zone 2, 3, 4, and 5, start to lay back, depending on how much land you have. Some people don't even have a zone 5. I mean, you almost need a couple acres, if not more, to have a zone 5. Zone 5 is kind of virtually untouched. But zone 2 is a little bit less intentional. Zone 3, a little bit more perennial, and zone 4 is almost entirely perennial. So here are some interesting things to take into account, as you can see on the strategy, zone 1 through zone 4 up above. And then how are you designing that property? So you may want to take a screenshot of this, or this is being recorded, so you can kind of be able to look at it slower later. But as I mentioned earlier, the house climate, the domestic sufficiency is really the most important part of zone 1. And then it also goes through how to establish the plants, the pruning of your trees, selection of the trees and plants, water provisions and structures. So this is kind of a neat layout, a neat little kind of tutorial about how do you treat each zone in your system, and when you do a design. Especially the water part. That's very important. But tonight, it's all about the energy. So I urge you to look at the bottom part there in terms of structures, because the structures are really where you gain the efficiencies of energy. And then here's just a little minor checklist that I'll probably have in every slideshow I do. But this is a fun little checklist to go through about when you're doing your observations to your property, or on your property and on your homestead or your backyard. And go through as the season goes on and you see rain and it snows and you have a windy day. All these circumstances are opportunities for you to observe how your environment, how your landscape behaves, and then understand all the different types of vectors and things that go on. So understanding what is going on in your property. This is a neat little checklist for you to be able to consider all the design inputs and variables that are on your property. So now we're going to get into energy saving solutions, now that we've talked a little bit about what permaculture design is. And I bring up just one quick little point here of why energy is so important. But here in Nebraska, electricity is needed for cooling. If most people have air conditioners, if you're lucky enough to have them. But obviously, if you're not, being able to open the windows and understanding how wind flows through the property to keep your room and your house a little cooler. That's roughly 4 months of the year that you are using an air conditioner or using some kind of electricity to keep things cool. And then the other opposite side of our season, because we get 110 in summer, and then we've actually, as we've seen this winter, we got -20. So we also need gas and electricity for heating in winter, and that's roughly 4 months. So there's at least 8 months. So 2/3 of your year where you're spending a decent amount of electricity for energy to keep yourself cool or warm. And we definitely need to use these energy solutions here in Omaha. And if you were to design your property with conservation and permaculture design in mind, hopefully you're reducing how much money and how much carbon you're actually burning and emitting when you are heating and cooling yourself and your family. So here's a neat little graph. You may not be able to read all the little fine print here, but it goes through all the different types of household appliances you may have and how much wattage. If you know what watts are, it's generally an easy way to measure how much does each appliance use, and then understanding how often do you use it. So there is this little plugin that's called a WhatsApp or What's Up or WhatsApp. Also, there's another one. There's also the kilowatt to kill your watts. So you plug them into the wall and then you plug your appliance into it and then turn on your appliance and it will tell you how much energy it's pulling. So there's neat devices to understand. But even without that, here are some kind of obviously this book was a little bit older, so it's it's using monitors and LCD flat screens, whereas some of this technology has improved. Some of our technology does use less than what is being on here, but this chart also shows you how to come up with watts if you're only being given amps or volts, and understanding how to measure and understand the energy that you do use. So I understand that. I mean, I think that's very important to at least understand what are the things you use in your house, uh, and then secondly, in the right-hand side is understanding a little bit about what your house or your apartment complex, how is it built? And then what are the materials used in your walls or your ceilings or your floor? What are those materials, and how are effective are they at keeping your room warm? I think there's ways, especially if you have a drafty window or a drafty door, those are very visible and easy ways to understand if you're not keeping yourself completely efficiently warm or cool, because those little leaks of air definitely add up and make your appliances that help you keep your environment cool or warm, they have to work harder. So these are neat little, and then the R value is a value, a number that is assigned to the how effective is that material, whether it's mineral fiberglass or urethane, how effective are they at keeping your place warm or cool and keeping it cool. Here's another important part, is the way and your house or your apartment complex, how is it oriented in terms of the prevailing wind, whether it's a winter storm from the north wind, that's always going to be a cold wind. So if you have a good tree belt, a windbreak, that is obviously ideal. You want to be able to block that wind. So as you can see on the right-hand side, that the wind is coming from a certain direction and you have a full tree there. This is showing a deciduous tree, but also conifers, pine trees are also effective, especially in winter because they have not lost their leaves. But you can see the height of that protection is important because it pushes the wind over your house so that your house and your windows don't have to deal with the pressure of a very cold or a warm wind. And then similarly, as you saw, it doesn't hurt to have actually trees kind of surrounding the house, because as you know, in Nebraska, the wind can come from any direction. And sometimes, that south wind is a hot wind in summer, and being able to deflect that wind so that you're not necessarily having to deal with the brunt of the heat, and also making sure that you benefit from the shade of some of shade trees reduces how much you need in air conditioning. So, and here's some neat kind of diagrams that I found in a solar book from the 1970s, but these concepts have not changed. So I kind of put these as cross sections here to look at, but what they're showing on the left-hand side is that you actually have a glass pane, so a big window, but it's not for looking out or looking out on your property. That glass pane, actually right in front of it is a black absorber, is what it says, glass or plastic. And that black absorber absorbs a lot of heat. If you notice when you touch something that's like a black car, the outside surface, the outside hood, if it's not on, even on a hot sunny day, it gets really hot compared to the hood of a white car. If you touch the hood of a white painted car, that it doesn't get nearly as hot. So just the color is of a surface affects how much energy you're absorbing on something. So this particular graphic shows that if you were to place a black absorber on a south-facing wall on the other side of a pane of glass, that it is going to start attracting that heat, and then that warm air is going to travel up the pane of a black absorber and then distribute itself in the room. And because it's going to start moving air, it's causing convection. causing air to move. So thereby, as you can see in these graphics, that it's pulling in the cool air. So it's going to displace. So cool air is being pulled at the bottom because cool air is generally at the bottom near our feet. And that's really why thermostats, if you notice a thermostat in your house, is generally placed right about at head level, because at our heads is where we perceive temperature the most. And so you understand that when you place it at 68 or 66 degrees in summer or in winter here, that's the comfort zone that you want right around your head. But then if you were to lay on the floor here in winter, that you can feel those cooler air. So there may be between, I'm about 6 foot. So between 6 foot and then down at 0 feet, there may be a difference in 3 to 4 degrees. So down there, it might be, 64 degrees or 65 degrees. And understanding that these differences in temperature, are managed through your HVAC system or through the way that your rooms are designed. It really comes down to whether or not you have return vents that are at the bottom, or do you have return vents that also kind of flip so that you can have a return vent in summer when you're using your air conditioning, and the return vent is pulling in your hottest air, and that hottest air is being pulled back into your air conditioning HVAC system to be cooled back off. So a lot of people don't, a lot of homes aren't designed that way. I think this is a neat graphic to kind of show the fact that, it would make sense if homes were designed to have, a flippable kind of supply air and return air system where you're able to catch that or return the cold or the hot air back to the furnace, when you need to do it. And then this right-hand graphic kind of does something similar. It shows the convection because on a south-facing greenhouse, and this is called one of my favorite ways to do a greenhouse, is called a lean-to. It's leaning to your existing structure, and it's facing south. It's not on a north face. It's definitely on your southern facing where the sun is most likely oriented in your winter. So it is absorbing as much sun as possible, and the low sun angle. That angle of the sun is called an azimuth. When it's really low in the sky, usually the lowest point is December 21st. So it's starting to creep back up in the sky when we know come July 21st or June 21st, that the sun is almost directly above us. And that's the point where, we get the most sun coming at us. So I'm going to move on, just to make sure that we're understanding this topic, because this ends up being one of the kind of the most important parts of keeping your house acclimated to a comfort level. So these are two neat concepts. So not only is there the world of photovoltaic energy and solar photovoltaic, we're actually converting the solar rays actually into electrical energy. And I think most people are familiar with that. So I'm not spending much time here with trying to talk about photovoltaic. What I have here is an example of what is called a hot water or solar collector. So the collector on the top it usually has a black absorber plate, as I mentioned earlier, something that's dark colored. That is the back face. And then running a copper tube or some kind of water tube snaking through that box. And it's usually also sealed by a really thick piece of glass. So that is a sealed system. So on a warm day like today, where we had almost full sun all day, that it is actually heating water as it's going through that tube. And then you can store that heated water with just a little bit of a pressure. You can use your existing water pressure of the house, or just run a mini pump to actually pump the in so that it is stored in your hot water heater. You can also couple it with a heat exchanger to make sure that you're not bringing in and you're not mingling your potable water that is going through this system and then also with the water that you could be consuming or you're bathing with. So you want those water cycles to stay separate. The other reason you want them to stay separate is because the water, it's not always sunny. And so sometimes you have to put a kind of an antifreeze in the water that is the closed loop system going into your water solar collectors. So that way when it's really cold outside or -20, that it's not going to burst those pipes in the water collector. So there's ways and tricks to make that happen. So that you're using less energy, so your water heater doesn't necessarily kick on as much as you need it to. And then secondly, to the right here, this is a neat little device and system from, the book from the 70s I mentioned. And it's really just having a little collector plate that angles outside of your house, maybe below a windowsill, so it's not obscuring your view of your yard. But this very simple collector plate has a divider plate in the middle, allowing the cool air to come in. And then as it's heated, once again, having one of those dark or black absorber plates, it has a chance, and also sealed in glass, it has a chance to go over the black absorber plate, getting heated up, and then that heat is then discharged into your living space. So all by convection, without a single moving part of electricity, this can all be done. So once the heat starts heating the air, it's going to start pulling that cool air into it. So this is a really neat demonstration of what can be done to create energy in your house without any electricity. So this is an age-old concept. It's something that obviously doesn't go into new homes, but it's something that's very simple that you could modify to at least assist your living space so it gets a little bit warmer. And obviously during the summer, you wouldn't really need this. So you would probably want to cover it in that context, and maybe cover the vent itself so air doesn't move through it. But this definitely has a very important use in winter. And then I touched on this earlier, but I like both of these together, both of these graphics together, because it talks about shading. And as much as we were conversely talking about the energy needed to heat a home, it's also important to know what can be done to reduce the amount of energy you need to cool your house. So you can see the difference between a deciduous tree here and the shade it can provide in summer versus the shade it is providing in winter. So in this context, a lot of people in Nebraska worry that you're planting a tree too close to your house, that the roots will get into pipes and ruin your foundation. And those are definitely things to consider. There are definitely risks with that. But having said that, uh, there are there are ways to encourage a nice shade tree to cover the what I consider the hottest time of the day in summer is usually about 3 o'clock. So the 3 o'clock sun, which is usually off to the right, if you're looking directly south, it's a little bit over here. Uh, that would be a great place to put a shade tree. And if you were to have shade trees covering some of your solar south in the summer, uh, you would not need nearly as much air conditioning. It would not kick on as much, and you could almost get away with just keeping the windows open and letting at least the air come out from the hottest part of your room and making sure it vents out. Other technologies called a whole house fan, where you keep your house kind of cool during the day, and then at night with a timer, the whole house fan just exhausts the hottest collected, usually in the peak of your attic, and pulls all that hot air out of your house, displacing it with the cool air of the evening hours. And you do it at a time when you know it's the coolest. Usually the coolest time of any day is between 4 and 7 o'clock, right before you're waking for the day. So timing and being able to have enough time to draw in enough cool air to displace your heated air from the previous day. These are things to think about. And then in the right-hand graphic over here is talking a little bit about that little visor, little piece there that is at the ridge line of, or not at the ridge line, at the roof line, right at the base where you would have your gutters. So if you can see in different contexts here, when the sun is in winter and it's at the low point, it's nice to get all of that sun coming right in, and then that shade piece doesn't come into play. However, in summer, when the sun is directly overhead, it's kind of nice to have a little bit of a shade or an awning or something like that that actually keeps the sun off of your windows and away from heating up your house when you are trying to keep it cool. So these are just neat little features that doesn't really cost any money. Or it doesn't really cost energy money to just reduce how much you need to spend on energy to heat or cool. And so these are things that being able to have a nice southern facing window and allowing that sun to pass in on a winter's day is great. But conversely, in summer, the last thing you want is the sun coming through your window. I think being able to block that and having an awning is something that just is something our grandparents used to know, and is a way to stay cool and comfortable. So a little bit, I'm going to say a little bit about solar photovoltaic. But when I talk about solar voltaic, I don't necessarily talk about it alone. I like hybrid systems. I think that if you are trying to not necessarily be off grid, but you are at least trying to make a decent dent in how much energy your household use, uh, I think wind turbines go well with solar panels. And I'm talking about small scale wind turbines. I'm not saying anything the big that you see when you're driving on the interstate with these enormous blades with huge semis. I'm talking about something that is, as big. Here they have horizontal axis ones. There are a lot of really neat technology you can build out of just little PVC pipes and just using little motor turbines. And the nice thing about wind turbines, when paired with solar panels, is that wind turbines are providing you energy usually when the sun is not out. So, and you may experience this living in Nebraska, that the sun doesn't always shine. I mean, we've been fortunate enough this winter, but I remember a few winters while I've lived here where it didn't seem like the sun came out for months during the winter. It was always cold and cloudy. Well, it's on those days that that's the perfect time to at least have your solar or your wind turbine would be making up for what your solar energy is not able to provide. One other thing you may notice here in the kind of comparison is that there's a higher efficiency with wind turbines. Granted, the solar panels technology is improving. It's saying it's about 15 to 20%. That's about where they're at now. They used to be only 8 to 10 to 12% efficient. So every year they're getting more and more efficient, and that's great. But meanwhile, the wind turbines have shown and proven, a much higher level of efficiency, and sometimes you can get a lot more wattage from wind turbines just alone. So as you can mention, and then down here, this hybrid setup, it's really not too much more complicated because you still would use a controller to be able to control the wattage coming in from each one of those. But basically, this would be a way for you to be able to provide all the energy that maybe your house needs. And then obviously you would need to know how many watts each of your appliances pull when they are on. Anything that is electrical with heat, so like toaster ovens or even Instapots, all these types of things that are rice cookers, water heater, just kettle water heaters. They use a lot of wattage right away to heat that element. And so understanding how many watts that uses and then how often do you use it. So these are all things to understand when you are sizing your system for solar panels and wind turbines. And I bring this up. So the water wheel is considered the most efficient method of collecting energy, period. So I mentioned earlier the efficiency of both the wind turbine and the solar panels. Uh, in a proper in a proper water wheel, and historically they were used at paper mills. That's why they were along a river, or logging mills, sawmills. So they usually are meant to turn a turbine, or turn a something. In this case, the picture's turning, an alternator to be able to connect and create electricity. But the rotation is all be determined by usually what is considered a stream that is not turning off and on. It's usually pretty constant. And so the efficiencies of a water wheel are sometimes about 99%. Or a river they can do things with, but I think the application is a little bit more at the municipal scale. Nebraska supposedly has more rivers and streams in miles than any other state in the entire country. We definitely could take a page from the water wheel designs, not just for you know uh, you know for creating energy. I think the most common way of doing um water energy is to dam water. And when you dam it, you're creating a higher drop of elevation, and that's not always necessary compared to what could be a water flow that is constant, and letting the fish and inhabitants just kind of live their lives without being interrupted by a big dam that breaks up the upstream and downstream lives and cycles of all of the marine animals. So this is low impact, and then it definitely creates a lot of energy. And I have one more example of water energy, and this is a really neat application. It's called the Schauberger uh, vortex. And the graphics in front of you, you can see it does look kind of complicated, but if you are understanding kind of what a centrifuge is, or the way a tornado works, that when there's a drop in water and you have a hole at the bottom, or when a whirlpool, or the way the toilet flushes, that you can feel all that water is creating energy and picking up speed as it gets closer and closer to the bottom. Well, the turbine is placed right in the middle of where that water slowly and then quicker and quicker picks up speed. And that turbine collects that energy, and that energy can be turned into electrical, or it can be turned into a mechanical form of energy. This Schauberger turbine is now, there are a few examples in Europe, but it's gaining popularity throughout the Central and South America. But this is a great use also because it does not disturb your marine wildlife. It's an offshoot from the river or the stream, and just grabbing a little branch of the flow of the river and the stream. So I consider this a really innovative way that doesn't really harm nature as it's being done. But obviously you can tell it definitely does involve some engineering in order to be able to do this on your river or stream. Uh, so I've kind of passed through a lot of the most intense urban and diagram parts of my energy discussion tonight, but I've left a little bit here to talk about energy as a context of your daily life. So I have this picture of 1917, and I believe this is in Delaware, about what urban gardening was like 100 years ago, 1917. And if you can imagine, the gentleman in front of us is probably living in one of the apartment buildings or the houses across the street. Well, think of how little energy it took for him to walk across the street and go pluck some beans for that night's dinner, compared to getting in your car or getting on a bus or getting on a bike and then going to the store and to do those things. So urban gardening is definitely conserving energy. It is allowing you to just walk out your back door, and then the 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 emissions, the carbon emissions that is usually tied to every mile, that is the way how many miles your food had to travel to get to your plate. Uh, Urban gardening, or gardening in your backyard, is definitely an energy saving endeavor. And I encourage everyone to try gardening, not only for the health benefits and how tasty it is, the fact that a tomato tastes really good, It doesn't taste like a store-bought tomato, but also because you're saving the world and saving the climate and saving the earth because you're using less energy. And then here's another example, a lot of community gardens that go around town, make their gardens and put them in raised beds. And in some situations, if you know that the soil has contaminants or toxins in it because they are in an urban setting, uh, there could have been lead in the soil. And in Omaha, we are one of the largest Superfund sites in the country. So we had the Asarco lead smelting plant here all the way in operation until 1998. So we do have those concerns. But if you were to get your soil tested and understand whether or not it is a compromised yard or not, a way to reduce how much energy is being used in your garden is to not have to use garden beds or raised beds, because the lumber of that's in front of you that you had to buy from a box store, that came miles, from the forest it was harvested in, usually in South America or Central America. Uh, there's a lot of energy behind the actual inputs in this garden before you've even gone out there and water and put your seeds in the ground. So, you know, being able to use just the soil in front of you is an energy saving endeavor. And I guess that's the only really point of why I left this slide here. And then lastly, back to our Fibonacci spiral of the pine cone and the pattern and how it's so important. To the left, we have one of the most iconic symbols in permaculture is the herb spiral. So this is kind of an overview, but if you can imagine on the side, an herb spiral actually is about 3 feet tall. So you are actually plucking herbs at a level about your waist level. But the reason I have this here is also because it has a topic of energy here. So the energy of the plants, the soil, the watering, the technique is all being densely put in this nice little spiral right outside your patio, right off your patio on the side. And you need less energy to walk out and pluck from this herb spiral on a day-to-day basis. It's not like you have to go out into your big garden field and start bending over and plucking and walk to some distance. An herb spiral is a time saving and it's energy saving. So this is a neat little kind of design of even these little practicalities. They do make sense, and they are saving energy. And here's another great example of saving steps of the year. We have early in spring, we have sown the seeds here, and our volunteer Jackie is watering in the seeds early in spring, just the way that our properties look like right now. Uh, and then the picture below it is the same vantage point, the same angle, the same garden, but we had no irrigation lines. This was just the existing rain. So the reason I put and left these slides here is because it also is about energy. No one had to run garden hoses out there every day or pull out a sprinkler or really, do much else to the property other than this initial watering in spring. So I consider that a time saving and an energy saving endeavor when you use more passive ways to grow your food. Yes, it's nice when plants can get watered every day. And if they don't, uh, they'd still grow. They may just need, they create a more modest harvest. But for the most part, if you grow enough and you plant enough, you do Omaha, at least Omaha, as in other parts of the state, but Omaha as a gradient, we still get about 30 inches of moisture or rain a year. That is combined with some snow, but that's less of that percentage. Lincoln, I think you also get about 20 to 25. You do have droughts and moments, and usually in June and July, it gets pretty dry. But offset, and as long as you keep the water on the property, it doesn't run off when it does rain for those big downpours. Being able to bank all that water in there and save it saves you energy and time. Here's another neat concept called the perennial edible sun trap. And I kept this in here also as a discussion of energy because you can see that kind of horseshoe design it's showing on the upper part. It makes sense for our climate because it's blocking the north wind on that back part of the horseshoe. And then on the front side, it's trapping the warmer energy. So in essence, you are able to garden in this setting in your perennial edible sun trap. You're going to garden probably for a month longer on the fall side. You're also going to garden probably a month longer on the spring side. So I might be adding 2 months to your growing season. And it's really a discussion about energy. It's keeping the warmth there longer and blocking the cool away longer as well. So this is a neat concept in permaculture, all about the design of your landscape. And that back part of the horseshoe, once again, just to reiterate, it is blocking your north side. So you do want to block from that north wind coming through. And lastly, I'm going to kind of quickly go through these, but I want to make sure you have any questions or answers. Actually, I see a question to answer or a question up there. Are lithium batteries the best way to store energy? So I personally am, and I think this is a good time to talk about that. I am not a big fan of lithium because when you can see how the lithium is mined, usually in Chile. Chile is the largest producer of lithium. It is mined up in a plateau area. And if you were to look at Google Earth and zoom into this plateau in Chile, uh, and then also listen to the inhabitants, the people that live in the nearby villages and have to use the rivers and streams around this lithium production. Uh, I am waiting for better battery technology to come through. Um, so lithium batteries are good, but I personally like the sodium batteries more. They're kind of the grade that is used more for your cars. Uh, so those sodium chloride batteries work just fine. They're easy to, there's even distilled water versions of batteries you can still purchase. And it just really, it separates the cathode and the anode of your battery, but you have to just replace the cells of the distilled water, probably depending on how often you use them. Excuse me. So there are ways to use other forms of batteries. And now that everybody is kind of jumping on the electric vehicle bandwagon and, mostly for good reasons, I'm seeing battery or car companies, namely some Chinese auto companies, combined with our very own Warren Buffett, has invested into this company that is coupled with Volkswagen and Chinese companies to come up with a graphene battery, also a battery that uses the sodium that I mentioned earlier. There's also a calcium battery. So all of these sodium is easily harvestable from salt water. Calcium is also very easily harvested and doesn't kind of destroy landscapes. So I'm sorry I addressed your question with a larger environmental topic here, but lithium batteries do they're so popular because they do have a very good energy retention and discharge and recharging rate. But uh, there is extreme promise with both all the methods I just mentioned, the graphene, the calcium, and the sodium. All three of them, there's ways to modify them that they can imitate and do everything that lithium batteries can do and last longer, and then be recycled better. Because there's very little you can do to an already used lithium battery. And so I guess not all batteries are created equal. And I can't wait for the battery technology, which has been the bottleneck of a lot of energy systems for so long. But now, the electric vehicle world is pushing this technology to move a little faster. So now I think we might actually see some really exciting battery technology come down the pipe that is not as toxic as what the lithium batteries can do. So thank you for that question. You let me go on a little rant there. I apologize, but thank you so much for that question. Um, so So here's another question or kind of a topic of what we're doing at Omaha Permaculture and how do we apply these permaculture principles. So we actually work with vacant properties, and a lot of these vacant properties have trees that are coming down. You know, they're older and they're being removed. And so we actually take the opportunity to mill these large trunks that still have good quality wood, and you can see we store them and dry them at a site on our site here in Omaha. And then we try to turn them into functional garden infrastructure. And as I mentioned earlier, you know, when I pointed out the community garden using lumber and wood that probably came from a box store, and probably that tree was harvested, you know, thousands of miles away, and they chopped down some forest somewhere else, you know. Whereas the way that Omaha Permaculture is doing it is we're working with trees that are already going to be pulled down in our local community. And so hopefully the miles traveled are within a couple miles. And then yes, there's a little bit of energy going in to actually do the milling, but there's actually no gas energy when it comes to the drying. We actually use solar drying kilns, or we just let it passively dry and strap down for another 8 months. We can be patient and let them dry and remove all the moisture that would be in that tree and that wood. Because if you go to other lumber companies and larger places, they actually use gas kilns where they intensely bake all of the wood that was just recently milled, and then in the course of a couple days, they immediately have some wood they could use, but not at the you know, without having to use a lot of energy. So we're hopefully trying to represent a way of creating a product, a wood product, and using an urban agricultural wood product with much less energy that would otherwise be used. Oops. I see up in the chat there. Okay. Okay. Um, there we go. All right. So here is an example of what we're doing with community gardens. And we have Tiffany here. And as you can see, we're also displaying a little bit of that garden infrastructure. We have picnic tables, we have garden benches, we have garden signs, and then way there in the back, we have a tool shed. All these things are using upcycled wood. That tool shed in the background is used from discarded pallets. And then we just had to put a roof on it and then put a lock on it so people can keep their tools on the property longer. So these are things that, you know, we use the wood infrastructure for. So we're hopefully applying these permacultures to vacant properties. And then we also try to promote people growing their own eggs through egg-laying hens in their backyard. And it makes quite a bit of sense to have a couple hens if you have a family, because you get a higher quality egg with higher nutrition than your store-bought egg. If you were to feed them an organic feed, and granted, organic feed is a little more expensive at the store, but you can reduce how much you need that organic feed by supplementing your food scraps out of your kitchen, as well as finding, you know, food scraps from your neighbors, all different ways to kind of add, you know, more things to integrate into your chicken's diet. One really fun way is to actually put little wood stumps that you know part of you know that are part of your wood pile in the chicken area, and every now and then, every week or so, is to turn them over, because underneath those wood stumps will have little roly polies, they'll have all these little insects under there, and then immediately the chickens will dive in there. And so you're creating like a little protein farm, so to speak, for your chickens, so that they're eating not just all of the things that you're coming out of your kitchen, but also they get to forage and they get to move around, and eat other things that are in your yard. But raising your own chickens is definitely a way of saving energy. It's producing your own food, because here in the depth of winter in January and February, when there's not much sun out there, and you can't really grow food as well, at least your chicken will be giving you a little protein ball every day. Some varieties don't lay as much in the winter, but there's some varieties that lay plenty. So that's a really neat way to kind of keep food coming out of your backyard. And then there are ways to grow food in winter, and these are called cold frames. And we have found a way to reduce the cost of building a cold frame by using materials that you can find at your box store. And then, as you can see, even in the picture below, we've even used like just sticks that you find in the backyard to help prop things up. So this is built with painter's plastic, bent electrical conduit, and then just your standard box 2x2s and 2x3s. And then hopefully you don't have to use the raised beds, but we did because we kind of have an urban soil problem. We wanted to make sure that our soil was safe. But if you didn't have to spend money on the raised beds, we're bringing the cost down below $400. If you were to buy a 12x20 greenhouse at a greenhouse supply store, you're probably spending over $1,200. So we host these cold frame workshops and show people how to build these at Omaha Permaculture. And then lastly, we've moved into new headquarters space at 41st and Grant Street. And we have a lot of these demonstrations on site that we'll have all year round. So you can even see what it looks like on a super cold, chilly day, and to see how all these energy solutions I talked about today, how are they used in practice, and how warm does it keep everything? But we are liking, we want to be able to host people here all year round. We're still building some of these and rehabilitating some of these old buildings. But we think that you can come and visit our headquarters, and where it is Earth Day every day. And then lastly is one of my favorite pictures. This is a kind of a countertop full of food. And it's really meant, this picture is meant to deter you so that you are not scared of starting your garden or doing anything in the backyard, because this particular bounty in front of us here was produced by a couple volunteers we had that were very ambitious and excited to plant things in May. But during the summer, they got busy, and it was hard to get them out to the property to do any weeding. So the property looked like really taken over by weeds, yet they had grown and seeded quite a variety of their vegetables, and even some fruits in there. So fruit trees all came from this property. Well, so we had no one weeding this property throughout the summer. So we went back in September and we're like, oh, well, let's see if there's anything growing there. Well, underneath all those weeds that had covered everything, we found all of this food. So even if you're lazy or you're really not good at it, let nature do the rest. And that's really kind of a major point in permaculture is permaculture will grow whatever you have in front of you. And yes, to different degrees. If we have a drought, it's not going to do as well. But for the most part, we do get enough rain here to encourage a growing season. And I definitely encourage you to try if you haven't already. And then lastly, is the last slide. Our mission is to foster community through sustainable land stewardship. My name is Gus Von Rowan, and Omaha Permaculture and permaculture itself is, I think, the best way to grow a better future. So thank you so much for coming out. Please let me know if you have any questions.
All right. So there's a couple that actually I have here, Gus. Oh, and I think Sarah, go ahead. Were you going to launch the poll for everybody?
Oh, yes.
Awesome. Yes. So you guys should receive a feedback survey for the event. Just go ahead and complete that real quick for us. It just helps us, gauge these events and, plan more fun events for the future.
Perfect. All right. So question for you, Gus. What tricks have you found save you the most energy in your work? And were there any struggles you have had while trying to save energy in permaculture projects that you've designed?
Well, that's a good question. Okay, so the first part, any tricks? I feel like I covered a lot of the little handy tricks that I like but the one particular that sticks out to me, uh, is using the south face of your house or your building to create a little sunroom. Or if you don't have the materials to build something formal, wrap something in plastic, with a little bit of ribs, because uh, even if you don't attach it like a lean-to as a greenhouse, like I mentioned in one of the slides, really just putting something that is blocked by the north wind. So even if it's not leaning to or attached to your building, at least it's being blocked. The coldest wind is being blocked by that building or that your house or something along those lines. I think that's probably it in our windy state. We get a lot of wind come through here. And then in winter, that is a cold wind, but it always ends up being at least, on the really cold days, it's almost 5 to 10 degrees warmer just by being on the southern face of something that's blocking the wind. I think that's probably the most valuable Nebraska related advice I can give for energy. I think obviously, all the other things I mentioned are all good and important too. And do you mind repeating the second part of that question again?
Yep, no worries. The second part's asking, were there any struggles you had while trying to save energy in permaculture projects that you've designed?
Okay, so I think that at least the projects that I've designed, it's the tech stuff. It's the if you want to get into wind and solar, uh, it's spending the money to have the the right technician to come in here and overlook everything, because you're using a lot of energy and it could be slightly dangerous. So and not everybody kind of dives in with both feet for that, and they kind of gradually work their way into kind of the solar and wind. But I urge you to kind of really work with someone that knows what they're doing. Maybe grow something in your garden to trade, or cook a nice dinner for an electrician. Uh, so I think that's a neat little trick is to grow and cook for trade, for skills that maybe you don't have. But in terms of energy, just being able to know that you're being more environmentally friendly with the energy that you do use is important, because you may start your permaculture design leaning on fossil fuels and furnaces and things, and that's fine. But being able to know that you're going to phase in a more renewable component of that system is something I challenge everybody to at least get there and work towards. I think that's really the essence and the most important part of permaculture. Great question.
Perfect. Another question, I do have one more, at least so far. What do you think are some of the more underrated methods of saving energy?
Ooh. So I felt like I was trying to cover a little bit of those topics, and it was mostly about like our energy of the day, and saving our steps and saving the energy of how much energy and maintenance it takes to do a garden. Uh, I think some of the easiest ways, I also, can kind of reiterate the point about just being able to do things on the southern face out of that north wind is important. And then maybe I didn't mention this, but in the hot summer, granted the sun is very direct, and so there's very little shade on the north side of places. But maybe spend most of your time while you're reading a book on a hot summer day, or you're spending time on the patio with some friends, that you do that in the shade of a tree. You do that in the shade of your house or your neighbor's house, instead of turning on the air conditioner. I think there are ways to get, obviously a hot day is a hot day, it's super hot, and even in the shade it gets hot. But I think there are ways to kind of be creative in using your shady spots as well as using your sunny spots in winter. So I think that's probably about as creative. And I don't think I did mention that about the shade. So
Great. Well, I am not seeing any more questions right now. Gus, is there any final thoughts? Anything you want to let us know in terms of reaching out, or any fun?
yes, well, no, thanks for the opportunity, Morgan. So yes, if you have any other further questions and you want to find out more, our website is omahapermaculture.org, it's all spelled out. And then if you make it to the website, there's a contact part of on the website, and I see those questions and I see those inquiries, and I'd be more than happy to help you with your own backyard project. So don't be hesitant. The reason we're a nonprofit is because we're helping people get into permaculture and learn how to do this. And I'm not going to charge you for any of this advice, so don't hesitate to ask the questions, because I'm more than happy to help everybody kind of get excited about permaculture.
Fantastic. Well, I will take a second to thank everyone for coming out. Thank you, Gus, for your wonderful time presentation. We sure love having you. And
Thank
I think that will conclude our event tonight.
Well, thank you.
Awesome. Thank you folks for attending. Thank you, Gus, Morgan. You guys have a good night.